Hi, my name's Chris O'Keefe and I'm the lab technician here for All-Fill's headquarters in Exton, Pennsylvania, and for auger fabrication based out of Downingtown. So in this multi-part series, we're going to be highlighting specifically agitation with our auger fillers. We're going to go through the types of agitation, the accessories we use for agitation, all the different settings and adjustments we can make in regards to agitation, and why it's important. We're going to highlight the effect of the agitation on actual physical samples, showing you an issue that's presented, and then showing you what one of these agitation styles does to fix that issue. So when it comes to agitation, it's a very important piece of our auger fillers in maintaining efficiency and accuracy in regards to the throughput of the machine. So without agitation, unless a product's incredibly free-flowing, we'll have issues feeding product down into the auger of the filler. Our augers rely on a consistent, uniform amount of grams per revolution, so the amount of product that's in between each flight. If that varies, that's where you start to see fluctuations in accuracy and overall performance of the machine. So these various types of agitation help with different types of products in gaining as uniform and efficient flow of product through the auger filler as possible. So when it comes to agitation, we have two different modes that we can set our agitation to: with fill and continuous. With fill agitation is exactly what it sounds like. It runs when we're running a fill cycle. So as the auger's turning, the agitation blade turns. So with fill agitation can have an off delay added to the end of it. So essentially, standard with fill agitation means that as the auger turns, the agitation blade turns. Once the auger stops turning, the agitation blade stops turning as well. We can add an off delay, which allows the agitation blade to turn for X amount of seconds after the auger stops turning. This is probably what 90% of our machines utilize. And the reason with fill is so useful is it gives you the amount of agitation that you need with an off delay as an option to add a little bit more, but it doesn't degrade your product. So the more we move the agitation blade, the more opportunity there is to degrade a product and cause densification or damage to the product. The other option is continuous agitation, and it's exactly what it sounds like. It's agitation that runs continuously throughout the production cycle, regardless of what the auger filler is doing. The only downside to continuous agitation is that we can have a lot of degradation happen to your product. Because regardless of what's going on, let's say your operator shuts the machine off and goes to take a break, the agitation blade will still be turning. With that, you now have product that's inside of that hopper that can slowly densify because you're making the powder finer, you're damaging granules and different particulates of product. So you can actually have a change in the characteristics of your product, which can change effectively the efficiency of the auger. You deliver more product or less product depending upon how damaged the product is. Some products, continuous agitation is absolutely a requirement. It's typically for a product that is either very non-free flow and needs additional continuous agitation to keep it moving down to the auger. Or you have a product that is what we call a tweener, where it has free-flowing characteristics but also non-free-flowing characteristics. Or in particular, a tweener that will actually change states depending upon if it's moved or not. So you can load a hopper full of a powder. That powder, when it's unagitated, will actually settle, compress, and densify on itself, causing the product to become very non-free flow. But once it's agitated, actually aerates and becomes fluid, almost like a liquid. And that changes it to more of a free-flowing characteristic. So like we've said before in other videos, these machines rely on consistent product characteristics, consistent product flow down into the auger flighting. When you have a massive change in characteristics or flow of a product, what you can run into is weight fluctuations because now the efficiency of the auger has changed. Varying amounts of grams per revolution are coming out of the auger, which can cause massive fluctuations. So continuous agitation can be very, very helpful in keeping the product moving and keeping it in a consistent, homogeneous state. It never has time to settle and become more dense or become overly fluid because it's a continuous motion at the same rate. So our agitation motors typically come with two different settings. We can go with 20 RPM or 40 RPM. The main difference between this is just how much agitation a machine needs, how many sweeping motions across the hopper is necessary. Standard is 40 RPM. but 20 RPM can be used in certain applications where we have a product that we don't want to damage, but it requires agitation, but minimal agitation. We can also use that for products that have, for instance, like a spice blend, where you can have separation between, let's say for instance, a spice blend that has paprika and like a parsley flake or thyme, some sort of a leafy product in it as well. What you'll notice over time with regular with-fill agitation is you can actually start to see the lighter, more light density product, the flake, separate out of your mixture, and it'll be a nice layer on top of the hopper. Obviously you don't want that because it's a spice blend. So typically what we'll do is we'll configure one of these agitation blades with a 20 RPM speed with no off delay. So it's as minimal agitation as possible to help alleviate the issues with degradation and or a separation of your mix of product. So what we're going to do now is I'm going to do a brief overview of some of the types of agitation blades and the categories of agitation that we have available for testing and for use in production settings. We'll do individual segments highlighting the specifics on each type of these. What we're also going to do is show before and after scenarios. So a product that would run better with a Flake Blade agitator, we're going to run it with a standard blade, show the issues that we're having. We're going to rerun it with the proper agitation blade and show the improvement that we get with it. So starting on the right side of the bench here, we have our standard slow speed agitation blade. So these are cut from blanks that we manufacture here at All-Fill, which I'll show you what that looks like. One of our standard uncut agitation blades looks just like this, and you can see the blunted edge on it. So essentially this gives us the ability to figure out what size auger and tooling you're going to have, and we'll cut it specific to the overflight of your auger so that the agitation blade doesn't hit the auger. So as you can see, once we cut it, there's a sharp profile there. This gives us a leading edge that helps push product down into the overflight of the auger. So the concept is we have a hub driven by a motor at the top at the center of our auger filler. This sweeps the outside edges of the hopper, following the profile, the inside of the conical hopper. So as it's doing this, what it's doing is grabbing all the product inside the center of the hopper, dragging it and causing it to collapse down into the auger overflight, allowing it to drag that product through and run as efficiently as possible. When you don't have good agitation, that product no longer collapses towards the center. You can end up with a void or a pocket, which we call a rat hole. Essentially, you starve the auger of product in the center, and this causes fluctuations in your accuracy, fluctuations in how fast you can package product, and you'll see all sorts of issues come from that. So the goal with all of these is to provide the auger consistent delivery of product. So this one we use on probably about 80 to 90% of all of our machines. It has this upper ear. It's sent with just about every one of the units that we ship out of this place. As we move from the right side of the bench over, we have essentially the same slow speed agitator blade without this upper ear that I had mentioned before. Where this can be beneficial is when you have a very light density product, typically a seasoning, leafy products, which we'll get into leafy products as well in this whole series, but you can have a product that's such a light density, the entire mass inside of the hopper, as this rotates around, will essentially move. The whole mass will spin. So instead of product collapsing in on itself, the entire piece is just pushing around in a circle and never feeding to the auger. So what you'll end up having is as this advances, product will build up, it'll catch that upper ear, and that upper ear is helping to drag that mass of product around the hopper. By removing the upper ear, we're able to help reduce the amount of mass turning that we have inside of the hopper. Some products, this still doesn't alleviate that fully, but there is a lot of products that have that issue. This tends to really help with the problem. Which brings us to our third type of slow speed agitation blade. This is what we call a flake blade. So this is very, very helpful for leafy products like thyme, parsley, light density spices. And essentially what this does is, instead of following the profile of the hopper, this is more targeted agitation. So the outside diameter of the overflight would be right about here. And now this hugs it very tightly. So this is causing any product that is around that overflight, directly in that area, to collapse, and it's helping eliminate that rat holing issue we were talking about. Now what's kind of nice is, let's say we have a product that really has issues with feeding, that's light density or is flaky, which typically we would use this. So we would implement this Flake Blade, and it would rotate and help collapse that rat hole. But let's say we're having issues where the outside product isn't moving now. We can actually run 2 of these in tandem on our hub with what we call double agitation, which can be 2 of this style, 2 of this style. We can marry up all sorts of combinations, but we would determine that through lab testing. But essentially now you've got a combination where the auger is in between these 2 agitation blades, and these both rotate, this helping with the rat holing issue in the center, and this helping to grab that product on the outside edges of the hopper and drag that forward. So it's a very custom thing when it gets into difficult products, light density products, and we have a lot of different variations that we can do to kind of attack these issues. And again, we're going to do specific highlight videos showing these being implemented in various different settings and different issues that we have here. With that, speaking of double agitation, I want to explain a couple of other oddball agitation blades that we do have. This is for a larger hopper than our standard 16-gallon hopper. This is for the 4 cubic foot hopper, I believe, with a straight side. But just to demonstrate the double agitation idea, this is perfect. So you can see that we have 2 agitation blades. Standard slow speed with a profile cut into here to help eliminate that dragging issue that we have with potential mass turning. And this is a unique little blade that we have as well. And essentially the purpose of this blade, it can be run in conjunction with one of these, or it can be run entirely by itself. We have level controls at the top of our hopper. Now these level controls, they rely on a consistent layer of product at the top of the hopper. So let's say you have an infeed system on one side. As that product's being loaded into the hopper, you're getting a mounding effect on this side of the hopper. The level controls over here, you can actually get a false reading from your level control saying that there's not enough product. Meanwhile, there's plenty of product that has been built up to one side of the hopper. What this arm does is it effectively sweeps the top layer without agitating the bottom product, because this agitation blade would not be there. And all it does is it takes that mound that has built up on the infeed side, and it helps to disperse that throughout the hopper, giving the level control the even uniform layer that it needs to see to shut off the infeed system. So that wraps up our slow speed agitation. Now we also offer high speed agitation blades, and there's a couple different configurations for that we'll go through right now. We have our standard high speed agitation, which is what we call a D blade. They come in 2 different sizes, a small and a large. Typically we'll use a large, and these are for wildly non-free flowing products, things with an oil content, a fat content, that really don't like to move without force. So we'll usually marry up one of our slow speed blades and a high speed D blade. This mounts in the auger shaft directly above the auger. So as this is sweeping on the outside edges, delivering product down to the center of the hopper, this is spinning at the same RPM speed as the auger. And what it's doing is it's helping grab that product in the center that's being delivered from the slow speed agitation. It's grabbing it and forcing it down into the overflight of the auger that's delivering product. So a good example of this is like a very fatty, moist cake mix, brownie mix, things like that. These are absolutely integral in getting a really, really solid efficiency out of those augers with an incredibly non-free flowing product. So in multi-fill applications, where we have tight centers with a lot of augers in one section, where you'd run a conveyor system underneath of it. Think of cups of instant oats that you would get at the grocery store. You peel the lid off, add hot water. Essentially what you have is, due to those tight centers, you don't have the room for any of these standard slow speed blades. They would hit, because what you have is a series of augers only a couple inches apart. to have a small footprint where you can fill several containers at one time. Having tight centers like that and being unable to use standard agitation complicates things because there's a lot of products that still need agitation in that design. So that's when we can turn to what we call an A3 style agitation blade. And these, with the help of a split collar, will connect to the auger shaft or the stem of the auger in some cases and be really targeted agitation in a very small footprint, which helps with a multi-fill because of the small centers. So essentially you can have agitation targeted directly around your auger and get the agitation you need without having an interference of one of these larger style agitation blades. So the final type of agitation we want to highlight is integrated agitation. So this is a very small auger, it's the number 7. And with our smaller tooling, there is a portion that we have a tough time reaching with our standard slow speed agitation blades. So what this is integrated targeted agitation just for these smaller augers. And we call it a wing wire agitator. So essentially it is a small wire with one wing on the auger. This wire, as the auger rotates, is agitating the product directly above the overflight of the auger. So this helps. We can run it in tandem with a slow speed agitation blade. And where the agitation blade cannot reach, this helps to grab that product, aerate it, get it to fall on itself and collapse down into the auger overflight, and then be drugged down through the flighting, yielding a very efficient auger. Well, thank you for tuning into Tooling Time. I hope this information has been helpful. On our next episode of this series, we're going to be highlighting the slow speed agitation blade and a lot of our standard applications, what this is used for. We're going to show a couple examples as well. So stay tuned and look for some new information from us soon.